All right, here we're given 3 points, and we're trying to we want to graph the figure and then find the perimeter. So if we're given 3 points, what kind of shape do you think that will be? If you guessed triangle, well done. That's right. So I'm going to plot -4, -1. So that's right here. -4 on the x, -1 on the y. 4, 5 is right here. 4 on the x, 5 on the y. And then 4, -2 is right here. Okay. So we have this shape. All right. So how in the world would we find the lengths of these sides? And for one of them, it's pretty straightforward, right? For this one, it's a vertical line. So I can just count the tick marks, right? Or just subtract the coordinates either way. But that would be 7, right? 1, 2, 3, 4, 5, 6, 7. So this is going to be 7. So that's not hard. But for the other ones, we can use the distance formula, right? So remember, if you want to visually trace out a triangle and do Pythagorean theorem, you can. I'm just going to use the distance formula. So let me label these points here. So this is A, B, and C, right? So let's find AB. So I'm going to use the distance formula. So I'm going to do, I'll use the B as my 2's. So I'm going to do 4 minus -4 squared plus 5 minus -1 squared. All right, negatives turn to positives. And so we'll get 8 squared plus 6 squared. And take the square root. So 64 plus 36 is 100. Square root of 100 is 10. So this length here is 10. All right, and then we'll do the same thing to find AC. So segment AC is going to be, we'll use our C's as our 2's, so we'll do 4 minus -4 squared plus -2 minus -1 squared. So that's going to be a couple double negatives again. So we're going to have 8 squared plus -1 squared. Don't forget to put parentheses around the negatives when you square. So it'll be 64 plus 1. So that'll be root 65. Now 65 can be broken down. It's not a prime number, but it's 5 times 13. So those are both prime and they don't match up. They don't pair. So this is as simplified as we can get, right? So once again, if they said to round, we would get a decimal value for root 65, right? We could just plug it into our calculator and find the approximation for that, right? It'd be 8 point something. But since they don't say to round, I'm going to keep it exact. So I'm going to add up all the sides, right? Perimeter of a triangle A plus B plus C. So it's just going to be 10 plus 7 plus root 65. And so it's just going to be 17 plus root 65. And our units, yeah, it doesn't say. We'll just put UN for units. One dimensional because we're talking about perimeter. So that would be our answer exactly, right? If it said to round, then we would plug 65 in our calculator, take the square root. And so it would be 8.1 to the nearest tenth. So if we were to round, it would be, or if it said to round, it would be approximately take that away. It'd be approximately 25.1 units. Okay. All right. So next we're talking about area. So here we're trying to find the area of these shaded figures. And so you can do this a couple different ways. You can do area by addition. If you have kind of one of these composite figures, you can just take all the pieces and find the areas and add them together. Or you can do area by subtraction, where you find the area of the total component, and then you subtract the area of the piece that's not included. All right. So either way works. Obviously, if you looked at what I just drew, if we did it by addition, we'd have to find 1, 2, 3 pieces. Whereas if we did it by subtraction, we only have to find 1, 2 pieces, right? So as long as you have enough information for that, I would probably go with that method. So first I'm going to find the area of the entire rectangle here, right? It kind of looks like a square, but it's not, because the sides are not the same. All the sides are not the same. But I'm going to find the area by doing base times height, right? So I'm going to do the green. So figure 1, the area would be 20 times 18, which would be 360 meters. All right. Then I'm going to find the area of the rectangle here. Call that figure 2. And so that's going to be base times height. So base is 10, height is 5. So it'll be 50. And by the way, I forgot to square my meters, right? Areas, square units. All right, and then the answer is going to be the area of figure 1 minus the area of figure 2, right? So I'm going to call this area 1, call this area 2. So the area that I'm looking for is area 1 minus area 2, right? So it'll just be 360 minus 50. So that's 310 square meters. All right, number 7, do the same thing. So figure 1 is going to be this value here. So area 1 is going to be base times height. So I'll start with the base, 12 times 8. And remember, commutative property of multiplication, you can definitely do 8 by 12 as well. So anyway, I get 96 square inches. For figure 2, it's a 4 by 4 square. So I can multiply 4 times 4, or I can do 4 squared. Same thing, right? So I get 16 square inches. And then our answer is going to be area 1 minus area 2. In this case, it'll be 80 square inches.